The same thing that makes this happen makes this happen. And this. It's electricity. Whoa.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by electrons, making your world a brighter place.
Hey, is your TV on? If it is, that's great. You're using electricity. But if you're watching the show and your TV's not on... Anyway, what is electricity? I mean, where does it come from? Is it just sitting in the wall waiting for us to use it? Or is it constantly spilling out of sockets and we don't notice it? And how can something so powerful be invisible? Well, electricity is the flow of tiny particles called electrons. And they're not just smaller than atoms, they're actually part of atoms. Take a look at this. It's our battery-powered electrical circuit of science. We're going to run this big light with this big battery. Watch.
Attention, the Nye Lab.
See, right now, electrons can flow from this side of the battery, through this wire, through the switch, through this wire, into the light, and back to this side of the battery. They're flowing in a closed path, what scientists call an electrical circuit. Now, circuit, that's from an old word for go around. So electrons, right now, can go around an electrical circuit. The flow of electrons is a lot like the flow of water. No kidding. Watch. When I operate this great big water pump of science, water goes through this hose into this box and makes this water wheel go around. And it goes out the other side and through this hose back to the pump. It's a closed path for the flow of water. It's a water circuit. It's just like the flow of electrons through an electrical circuit. Electricity is a very versatile form of energy. The same electrons that are making the light light up are making a motor go around. See, electricity can do all kinds of different jobs, and they're all done with electrons.
Electrons flowing through a wire are a lot like water flowing through a hose. When we got the flow going, we can do work.
Bumper cars have electric motors. The electricity runs from the rod that touches the ceiling, through the electric motor in the car, and then to the floor. So you don't get a shock from the floor unless you can touch the ceiling at the same time. Otherwise, it's not a complete circuit. Sirens!
Keeping batteries in the refrigerator makes them last longer. Your brain uses the same power as a 10-watt light bulb. Cold metal conducts electricity better than hot metal.
Now you know!
There's enough electricity coming out of the wall to stop your heart. So don't stick anything but a plug in a socket. Be careful. This is Godzilla's hairdryer, I think.
Check this out. It's an electric train. It has 2 rails. Electricity goes in one side, through the motor in the engine, then back out the other side. It's a circuit.
So where does electricity come from, anyway? Well, in 1831, two scientists figured out how to make electricity. It was Michael Faraday, working in Britain, and Joseph Henry, working in the United States. And about the same time, they both did an experiment, something like this. Michael Faraday took a coil of wire and he moved it over a magnet. And when he did, electricity started to flow in this coil. The electricity went down over here to another coil and made a compass needle move. Well, Michael Faraday was doing this experiment for an audience, and a woman came up to him afterwards and said, Mr. Faraday, of what use is it? And he said, Madam, will you tell me the use of a newborn child? And what he meant was, would you take a look? I mean, I'm moving the compass needle without touching it. You understand? I have a coil of wire way over here, and I'm making a compass needle move way over there with no apparent force. I mean, some force is going right through the air and wiggling that needle. Something's happening here. Some spectacular effect is happening here. You may not completely understand it right now with no apparent force. One day we will, and it's going to be a big deal. Thank you for joining me on